In the circuit given, we are supposed to find the values of Vmax and Vmin, which are actually the maximum and minimum values attained during the charging and discharging when the simple RC low pass circuit is subjected to a unipolar square wave. Now, in the original question, we are given the values as the on time and off time of the square wave are given to be T1 and T2, but for simplicity we will be considering them as equal, and also the that time will be equal to one time constant. It is to further simplify the equations. In general, the concept is this underlying concept is same, and it's not like useful to waste time on unnecessary equations, big equations. Okay, so considering this, we will largely simplify our equations. So let's go forward this assumption. So the time constants are either on time off time are equal and also equal to one time constant tau. Okay, yeah. So in steady state, let's analyze first what will happen to the RC low pass circuit. uh, we have a square input, and it will charge to a maximum value Vmax because it doesn't get sufficient time to fully charge to the voltage A, and in the off time it will try to fully discharge, but also in this case also it doesn't get a like sufficient time to fully discharge, so it will attain a minimum value Vmin, and from this value again it will start to charge again to a value Vmax, and the uh, cycle repeats again. So now we have this equation for describing curve B. The curve B describes the charging part, curve C describes the discharging part. Now you might be wondering, how did I write this equation? So to understand this, let's first analyze a simple RC charging circuit. So we have, I will draw here, we have a like I suppose have this, I have a step input. Okay, step input, till this part it's simply like a step input. Okay, uh, so we have a step input, and the voltage across the capacitor will be given as A times 1 minus e power minus t upon tau, t upon tau. So initially the capacitor was uncharged. So the impulse that is being applied across the capacitor, or the shock that is being given to the capacitor, is actually the value of A initially, because it is uncharged. So the V initial, like uh, I should I am writing the initial charge as V0 minus. Okay, so initial charge, that was the initial voltage that was the capacitor was carrying, was 0 volts, and suddenly the impulse that is being applied is of A volts. So A minus 0 gives A, so the impulse is A. So we write this equation, and if we apply a similar logic, okay, the capacitor was initially having a voltage of VC at 0 minus, we had a voltage equals Vmin. So the impulse now that is being applied by the step voltage A is V A minus Vmin. So this is the step voltage that is being applied to the circuit. So A minus Vmin actually represents the step voltage, which is analogous to A in the simple RC circuit step response, and 1 minus e power minus t by tau is similar. Because we are considering at a time t equals tau, that is at this time the capacitor is actually charging. So let me clear out this mess. Okay, the capacitor is charging from a minimum value to a particular value we are calling Vmax in time t. So at in time tau, which is time t equals to tau, it is being charged to a value of Vmax. So Vmax will be Vc will be equals to Vmax when t equals tau. Okay, from that I have written this equation. Now that the charging part is clear, let's go into the discharging part. So this is the discharging part, and the equation governing will be, see, when we analyze a discharging circuit, RC discharging circuit, what do we get? The initial voltage V in, okay, the VC initial, let's assume like this, and the voltage across the resistor or the capacitor voltage and the resistor voltage will be equal, just that their signs will flip. So the voltage here, the voltage of VC will be VC initial times e power minus t by tau. Okay, so I have written the same thing, and at t equals to tau, this is the time interval, this the interval time interval is tau. So at t equals to tau, the voltage across the capacitor will reach a value of V min. Okay, so at t equals to tau, if I substitute t equals to tau here, I will get V minimum. So it should have been Vc, okay, Vc, and this Vc at t equals to tau will become V minimum. So the initial charge was V max, so initial charge was V max, and we get this equation. Now we solve both these equations 1 and 2. Upon solving these two equations, I get V minimum as A times e power minus t by tau, A by e plus 1, and V max I get as A e by e plus 1. So that's it for this video. We will have a even more interesting approach of looking at this circuit in the further video, so stay tuned for that.